All right, Algebra 2, this is video 1.3.2. We're going to be solving single direction inequalities. Make sure that you go ahead and write that at the top of your paper, and let's get started. All right, here's our first example. I'll give you a second to write it down. Pause at any point throughout the video if you're going to need extra time with this. Okay, so we're going to go ahead and solve this. I am going to use the inverse operation method. You're welcome to do it another way if you'd prefer. So I'm going to start by talking about what happened to x, and that is that we multiplied by 4. Then we subtracted 6 and we ended up with a 10. Working in reverse, we're going to add 6, which gives us 16. We're going to divide by 4, which means x is, keeping the symbol exactly the same, x is greater than or equal to 4. So we're going to write this three different ways. The first way is we're going to write it as an inequality. And our inequality is simply x is greater than or equal to 4. The second thing we're going to do is we're going to graph this on a number line. Now your number lines don't have to be super detailed, but they do have to include the number that you are talking about, which in this case is 4. I also like a reference for 0, so I would say let's go with you have to have the number that's there and you also have to have 0. So I'm going to put 0 on. And I'm going to put 4, and I'm going to use a closed circle because this is inclusive, and then I'm going to shade everything that is greater than 4. So we have our inequality, we have our graphing method, and then we're also going to use our interval notation. All right, so with the interval notation, we're going to say, well, where does it begin? And it begins at 4, and it's inclusive, so we use the square bracket. And then we say, where does it go to? It goes to infinity. So from 4 to infinity. If I were to say this out loud, as if I were to read an answer to someone or communicate it, and they didn't have paper in front of them, I would say the solution to this inequality is 4 to infinity inclusive. And that's how I would explain it. It's from 4 to infinity inclusive. All right, let's go try another one. All right, here we've got another one. Let's take a look at what's going on here. Give yourself a second to write it down. Pause if you need to. And I say, well, what happened to x? Well, first we subtracted 5, and then we took whatever we got there, and we multiplied it by 2, and then we added 9, and we got a grand total of 11. So working in reverse, I'm going to subtract 9, which gives me a 2. I'm going to divide by 2, which is going to give me a 1, and I'm going to add 5, which gives me less than 6. I'm not changing the symbol because I didn't divide or multiply by a negative number. So our three ways of writing this, x is less than 6, that's using an inequality. The second way, let's use that number line. I'm going to put 0 on, I'm going to put 6 on, open circle because it is exclusive, and we'll shade everywhere that is less than 6. And the third way would say, let's write this using interval notation. That means from negative infinity up to 6, and we do not want to include it, so we use the soft bracket or the parentheses. Got another example for you. Let's take a look at this one. This one's got some fractions, so we're going to use a different method. It also has x's on both sides, so I am going to have to use a couple different steps here. So if I want to eliminate a 1/2 and a 5/3 and get rid of the denominators, I'm going to choose to multiply everything by a 6. When I do that, 6 times a half is 3. Don't forget to multiply to these constants, so that's 18. Less than or equal to 6 over here. If I multiply 6 times 5, I get 30. 30 divided by 3 is 10x, and then minus 12. So I need to move all of my x's to one side and all of my numbers to the other, so we can do it that way. I'm going to start by subtracting this 10x from both sides, and that leaves me with negative 7x plus 18 is less than or equal to negative 12. Then I'm going to subtract the 18. So I'm doing this I am using inverse operations. I'm just not organizing it the same way as I had in the previous two. And that leaves me with negative 7x is less than or equal to negative 30, which we will divide by a negative 7. When we divide by negative 7, I need to address what happens with the numbers on the right side, the negative 30 divided by negative 7, but I also need to flip my symbol. So this becomes, in inequality form, x is greater than or equal to, and a negative divided by a negative is a positive 30 over 7. Using a number line, I will have a 0 and then 37ths. See, I don't even know where 37ths is. I mean, I can approximate it, of course, and I don't need a calculator to approximate it, but I'm just saying, hey, it's on the positive side of 0, so let's just put it there. Let's go inclusive with that. Oops. Inclusive with that, and then shading greater than. And lastly, let's write it as interval notation, and that would be a square bracket from 37ths to positive infinity. All right, so this last problem had a bunch of steps on it, and it could have been done a couple different ways. Think about a different way we could have solved this. Maybe we didn't want to get rid of the fractions. Maybe you moved the 3x over and kept your x's positive with a positive 7x. Would you have gotten the same solution? Consider all of these things. It makes for good arguments and really convinces you that you understand what's going on. Great job with these examples.